didn't even look at it. I didn't even worry about it.
Hey, is anybody willing to jump in their Chromebook for me quick and just make sure that that's streaming okay for somebody that I had a couple kids that wanted to do that second hour, so.
I did. With the equation.
What's that?
And then I did the x squared.
Well, yeah, but this is second hour right now.
And then
All right, kids. Hey, get started here.
And then there's a
3.6 is kind of a, well, this is kind of an important one for you guys moving forward. So, 3.6 is titled The Fundamental Theorem of
I
Algebra.
don't know how this works.
And really what we're trying to ask ourselves is how can you determine whether a polynomial equation has, here they are, they're here. What kind of solutions? Imaginary solutions, and I'll show you how they come up with those in a little bit. I think you may have talked about that a little bit last year. Quadratic formula gave you some imaginary roots when you did that, but we'll refamiliarize ourselves with that as we move forward. So we're going to talk about the fundamental theorem of algebra. We're going to find conjugate pairs of, oh my gosh, complex zeros of polynomial functions. Guys, conjugate again. If I have an expression, x plus 2, what's its conjugate? If I have x plus 2, what's the conjugate of x plus 2? X minus 2. Yep. Okay. And then this guy's got a rule of signs right up here. We're going to use this so-called, it's called Descartes' rule of signs. I'll show you what that means here in a little bit. All right. So those are goals to accomplish today. Let's talk, kids. Complex conjugates. Complex conjugates are the following. If you have something like a plus bi, then the conjugate of that is a minus b times I. All right, so you're going to see some of that today. Guys, repeated solutions. Have we talked about repeated solutions before? It's an answer that shows up more than what? Once. It's a repeated solution. We've talked about that before. So it's an answer that shows up. It's an answer that shows up more than once. Okay. So as an example, suppose I had this. Suppose I had that, x plus 3 times x plus 3 equals 0. In that first quantity, what's your root? What value is going to make that statement true? What would go in here to make this equation true? Right here.
-3.
And what would go in here?
-3.
So -3 is what type of a solution? Yeah, repeated solution. We would call it a double root. Okay, good. Guys, we know degree of a polynomial. It's the highest power. It's the highest power. Of a term, or of a polynomial, I should say. So if I give you this right here, 3x squared plus 9x to the 7th minus 12. What degree is my function? Degree 7. Okay. All right, degree 7. Okay, solution of an equation is just any x value that makes the equation true. So a solution of an equation is any x value, or values that make equations true. So it's any x value or values that would make an equation true. Okay. As we talked yesterday, we said if you hear the solution of an equation, root or zero, they all mean the what? Same thing. You bet. So the zero of a function is considered a solution or an x-intercept. Okay, so a zero of a function is a solution. It can be called a root, or it can be called the x-intercept. Okay. And we need to remember what conjugates are. Conjugates are, they're binomials that have opposite signs between the two terms. So if I have this, I would say x plus 7 is a conjugate of what? X minus 7, yep. What's the conjugate of cat minus dog? Cat plus dog, which usually doesn't go very well.
I was about to say dog minus.
All right, I'm going to give you a second to make sure you got it all down. There's a lot of writing there, so I see the smoke coming off of your pencils right now. Guys, where do imaginary roots come from? Anybody know?
You don't need to write these down.
Mrs. Hill talked about this with you last year.
That's going to be sick, so you don't even need to.
Let me jot this down up here over here on a board.
It's like that. 1/2.
Let me ask you a question here. What's the square root of 25? Call it plus or minus 5, right? Okay, imaginary numbers come from this right here. This is what it means. Okay, you cannot take the square root of a negative because two numbers multiplied together would give you a positive, to the same number multiplied. So what we say right here, guys, is this is like the square root of 25 times the square root of -1. What is the square root of 25 again? So let me say this is plus or minus 5. Anytime you take the square root of what kind of a number, what do we have down here? Negative. We call it imaginary. Okay? And the reason is this. The reason is this. There's no such number, both positive. Can I take two positives to multiply them together to make a negative? Can I take two negatives and multiply them together to make a negative? So in order to keep with our rules of polynomials right here, we have to assign something to this right here. Now I want to show you this right here. Very top of your notes, you might want to write this down. Square root of -1 is equal to I. All right? You might want to write that part down. Okay? Now, watch this. If I take I and square it, multiply it by this again, you might want to know that I squared is equal to, what if I square this? What happens to the square root sign? This goes away, doesn't it? Okay. In mathematics, if you see I squared is going to equal what value? Okay, I'm going to give you the last two that you need to know. I to the 4th, my friends. Anybody know what that is? All right, I'll just tell you it's negative. How do I want to do this? I think I'll just call it -1I for you, make it simple for you. I to the 3rd is the same as -1 times I. And then I to the 4th, my friends, is equal to 1. And that should be as far as we have to go with it. So make sure you have this down. Why is I to the 4th equal to +1? Wouldn't I squared times another I squared make I to the 4th? So it's like -1 times -1 would make what here? +1. Okay. And then after that, the pattern just starts repeating itself again. So I to the fifth would be the next one. The pattern just starts over again. All right, but have those four written down at the top there. All right, let's see what we can get into with this. Let's go to the first page here. Oh my gosh. Oh my gosh. All right, let's talk here, kids. It says the table shows several polynomial equations and their solutions, including repeated solutions. In the last equation, the repeated solution is x equals negative 1 is counted twice. So where did I pull this from? All right, I'm going to start right here, kids. I'm going to give you an equation to work with. Whoops. Put in 2x minus 1 here, kids. And put in 2x minus 1 is equal to, let's go 0. Okay, let's see if we can't put some stuff together. We've kind of talked about this already in the previous section. But guys, what degree is my function here? 1. Now, if I solve this right here, kids, if I solve this, what would your x value equal? Not 2. Other way around. Add 1 and then divide by what? So wouldn't x equal 1 divided by 2, which is... Okay, so how many solutions does this have? 1. All right. Keep that in mind. Let's do this. I like this one. Let's go x squared plus 2, all right, equals 0. I'll put some work over here for you. X squared plus 2 equals what again, kids? Okay, so what would I have to subtract from both sides? 2. Now we're so used to saying if I square root right here, what do we get on the left? Okay, and then if I square root here, you're so used to saying I can't take the square root of a negative, therefore what? No solution, right? But the deal of it is this. This is kind of like square root of negative 1 times the square root of 2. And what is the square root of negative 1, kids? So we call this x equal plus or minus I times the square root of 2. Keep in mind, square roots can either be positive or they can be what? Negative. Now this is going to be a big concept throughout this. It can be confusing. What degree was this function right here? Second degree, right? The solutions to this would be x equal plus or minus I times root 2. Friends, how many solutions is this? 1's positive, 1's negative. Now, are they real solutions or imaginary solutions?
Imaginary.
They're imaginary, but solutions nonetheless. So really, how many solutions do we have there? 2. Okay, let's take a look at this next one. I'm not even going to write this down this way. I'm going to write it as the following. I'll write it as, okay, how about can I just write this table in here for you? Do you trust me?
Sure.
X cubed plus x squared minus x minus 1. Kids, if I factored this, set this equal to 0. By the way, what would be your best way to split this, or to factor this?
Split it.
Split it! Good, good. You would split it. Whew. Thought I didn't let the cat out of the bag there. How many solutions, or I'm sorry, what degree is this?
3.
3. All right, I'm just going to tell you your solutions here are x equals 1, x equals negative 1, x equals negative 1. Now, guys, how many times did negative 1 get accounted for? Twice. It's a double root. If you would have factored that, you would have factored that down into 3 different parts. Negative 1 would have shown up twice. But realistically, how many solutions are up there? There's really 2 values that show up, but how many times do I have to account for negative
3.
1?
2. So it's 3 solutions.
Twice. So there's really 3 solutions where negative 1 is considered a double root. Guys, the whole idea behind today is this. what do you notice about the degree of a polynomial as it relates to the number of solutions for a polynomial?
1, 2, 3, 1, 2, 3.
So if I have a degree 7 polynomial function, or I should say a degree 7 polynomial equation, how many solutions should there be? 7. That's all the fundamental theorem of algebra says. Whatever your degree is in an equation of a polynomial, that's how many solutions you'll have. So if I have a degree 22, you better find 22 different answers. But can answers be accounted for more than once?
Yep.
Are some answers real?
Yep.
Are some answers not real?
Yep.
Okay, that's what we're looking at today. Okay?
That could be any.
So, core concept down here. This is really what it says. There's a lot of, guys, I'm not really going to read this whole thing because this really says the following. This says that if you have a degree of 2 in an equation, then
2 solutions.
your number of solutions is what?
2.
I'm not going to read this because this pretty much says the same thing. All right? I'll make sure there's nothing pressing here. I'll read it to you real quickly. So it says if f of x is polynomial of degree n where n greater than 0 and the equation f of x equals 0 has at least one solution in a set of complex numbers. Corollary, if f of x is a polynomial of degree n where n is greater than 0, then the equation f of x has exactly n solutions, provided each solution repeated twice is counted as 2 solutions, each solution repeated 3 times is counted 3, and so on. Guys, this is just a really fancy saying for if you have this degree, how many answers are you going to have? That one, okay? Does that make sense, what this is really saying now? All right, well, let's move on, friends. Example 1. This here says the following. How many solutions does f of x equal x to the 4th minus 22x squared minus 75 have? Okay? Guys, you might want to get into your Chromebooks. You remember this little calculator here before?
Kind of.
Remember this guy? Yeah, you might want to jump in on your Chromebooks today. And we're going to do some factoring techniques today to do some factoring. So you may want to jump into that. First of all, in this right here, by fundamental theorem of algebra, the question says, how many solutions does this function have? 4. Okay? And I should really have called this how many, and you might want to write this word in up here, how many zeros does this have? So it's going to have 4, it's going to have 4 zeros. Okay, why 4 zeros, kids? Degree 4. Okay, and then it says find all the solutions. Well, guys, we've got to go back to ideas of factoring. So I'm going to split this right here. Think factoring. And when I think factoring, I'm going to save you some time by using this up here. So I'll open up the page so you can see it here. But we're going to set x to the 4th minus 22x squared minus 75 equal to what value, kids? Okay. I know what this is going to factor to. I'll show it to you in this here. I notice that this is double of this right here, so this is going to factor into x to the 2nd. Oh, let's see, minus 25 times x to the 2nd plus 3 equals 0. And let me jump in there quickly. Guys, just take a look at my logic up there. X to the 4th splits into x squared times x squared, doesn't it? So wouldn't the x squared here and the x squared here make your x to the 4th?
Yeah.
Wouldn't the minus 25x squared on the insides and the plus 3x squared on the outside become negative 22x squared?
Yeah.
And wouldn't minus 25 and plus 3 make that negative 75? Okay, and we're still equal to what value here, kids? 0, right? Okay, now, can this factor further right here, the x squared minus 25?
Yes.
X plus 5 and?
X minus 5.
So you would have x plus 5. Oops, times what else, kids? Can this factor? Can't factor that. Okay, I just want to show you something real quickly. All right. Again, I know factoring is kind of a stumbling block for us at times, so we can confirm this right here. If you guys jump in right here, this might save you some time. Let me go here quickly, kids. Whoops.
Okay, let me go. So on the website right here, so it's under online calculators and resources. Oh, guys, do you remember which one it was? Factoring calculator. Way at the very bottom, it's a factoring calculator. Can somebody tell me what the original function was that we started with? It was x to the what?
You were in it.
Was it minus? You said 22, Haven?
Minus 22x squared.
Okay, so I got to type it in like this.
Minus 7.
Minus 75. Okay, and then calculate. Oops. Okay, we'll hit calculate it. Do we have the right part for the factored part, kids? Did we get x plus 5, x minus 5, and x squared plus 3 here? Okay, so guys, I think that going through this section, I might encourage you to save a little time or double check your factoring with that right here. But here's the deal now. When we jump into this, we say, okay, well, how many parts do I have right here? Then? 3. We've got to set all 3 parts equal to 0 then when I solve that. So right here, we run into a situation where we say, okay, I've completely broken this down. And now what we're going to do here is this. We're going to set x plus 5 equal to 0. We're going to set x minus 5 equal to 0. And we're going to set x squared plus 3 equal to 0. Okay, let's talk about solutions here. Top left one, x plus 5 equals 0. That's easy. What's your solution there? Did I hear negative 5? Is that what you guys said? Okay, what's another one easily?
5.
Okay, now the one that could be a little difficult. Where are my tools? Okay, the one that could be difficult here then is this. My solutions are going to be x equal 5, x equal negative 5. Guys, when I come to this one right here, this x squared plus 3 equals 0, to get x squared alone, doesn't this become x squared equals negative 3? And then what would you have to do? You'd have x squared equal negative 3, so to get x alone, you'd have to take the square root, wouldn't you? But the square root of a negative number is going to be what kind of value, kids? Imaginary. So from this one right here, you'd say, well, this is like x squared is equal to negative 3, which means x could equal, here's how you write this, plus or minus square root of 3, but that square root of 3 is that a real root or an imaginary root? You took the square root of a negative right there. It's imaginary, so you got to put plus or minus I root 3. Kids, I have a question. How many solutions did we end up with? 4 then. How many are real solutions? How many are complex or imaginary, if you will? 2. But nonetheless, how many total solutions? 4. Right? Let's try another one. Let's use the math papa to help us out. What degree do I have in example 2, friends? 5. Okay, so when I go 5 solutions here, right? We want to find all zeros, so that means take this thing, set it equal to 0. I don't feel like factoring that, or I don't feel like using rational root theorem right now. So who should we call? Math Papa. Okay, let's do it. All right, let's factor this puppy out. Who are you gonna call? Math Papa. I love it. All right, I know it started out x to the 5th, kids. Whoops. I need help.
Plus 3x to the 4th.
3x to the 4th.
Plus 9x to the 3rd.
Plus 9x to the 3rd.
Plus 23x squared. Minus 36.
You said squared?
Yes.
There's no x term?
Minus 36.
Okay, do you guys see why we have this calculator now?
Oh, yeah.
All right, so what's this factor into, kids?
X minus 1.
X plus 2.
X plus 2.
You guys take a minute and write this down and then relay it back to me once you've all got it so I can get caught up with you.
X minus 1. X plus 2. X plus 2.
Let me know when you've all got that written down, and then I'll go to my page and we'll transfer it over. Y'all got them? Okay, so help me out here. I'll remember x minus 1. So this factored into x minus 1. I could have been a mean guy and said, do all your constants, figure out which ones work. You wouldn't like that, would you? What was x after x minus 1? Was it x plus 2? Did that happen twice?
Yep.
And what's the last? Must be x squared plus 9. Okay, let's talk about solutions here. For this one, these first three are nice. I like these. X would equal 1.
Equal negative 2 and negative.
Okay, now watch what I do right here. You might want to get in the habit of doing this. I put negative 2 and then I put dr after it. Anybody is
Double root.
double root. Okay, I thought it was the doctor. Got the math pop and the doctor in the house today. Probably should stop. Okay, now, how many solutions do we really have right here so far?
3.
3.
The part that we're going to struggle with is taking this x squared plus 9 and setting it equal to 0. Okay? And hear me out on this. Do you agree that this is x squared equals negative 9?
Yes.
So if I square root this and I square root this, do you guys agree that this is x equals really the square root of 9 times the square root of negative 1 like that? Would you agree with that?
Yep.
Well, what's the square root of 9 in this case? 3. But this here is I. So my solution here really is plus or minus 3 times what? I. Now, in the last one, we had to leave it as like I root 3 because 3 is not a perfect square up here. But guys, is this 9 a perfect square that's in here?
So can you make 3i?
Yeah, so we can just call those last ones x equal a plus or a minus 3i. Okay. Hey, quick question. How many solutions did we come up with?
5.
And by fundamental theorem of algebra, we should have come up with how many?
5.
Because our degree of the function was
5.
5. All right? Are you guys all clear on how to get to the website to factor this stuff and save yourself some time right now?
Yes.
That's what I'm concerned about. Okay? All right. Questions about this page? You guys have everything down right now?
Yes.
Anybody need more time yet? And I should circle my solutions. My solutions are all right here. Where are you at? Right here? Is that it?
Above it.
Square root of negative 9 is what that was. Because I had to subtract 9 from both sides to get x squared alone up there.
I'm done.
Good now? Okay, let's roll. Next page and see what we can find here. Okay, another core concept. This is called the complex conjugates theorem. And the complex conjugates theorem states the following. It says if a polynomial function with real coefficients and a plus bi is an imaginary 0 of f, then a minus bi is also a 0 of f. Simply put this, kids, if I had something like 3 plus 6i is a root, if I say, hey, 3 plus 6i is a root, what else must be a root? Then its conjugate must be a root. Okay, and this is all coming from quadratic formula stuff. So 3 minus 6i would be a root. Okay? So in example 3, it says, use your zeros to write a polynomial function. So in this example, they say, write a polynomial function f of least degree that has rational coefficients, whole numbers in other words, a leading coefficient of 1, but they tell me the zeros are what? 5 and 1 plus I. Guys,
And minus I.
yeah, so another root, so another has to be what? Another must be, whoops, another must be
So what the third power?
1 minus I. Now, do you guys have this chart down right here? The negative.
First one's x over 3.
Do you guys have this down right here?
Yep.
Okay, you might keep an eye on that up there. Okay, so here we go. My polynomial function will be the following. I'll call it f of x. Guys, what's our real zero in this?
5.
Okay, we've got to write this as x minus 5. Okay, and then here we go. What's one imaginary root? X minus and you guys all agree with that? X minus 1 plus I and x minus 1 minus I, right? Okay. We have to multiply this whole mess out. You guys want to guess what part I'm going to tell you to start with?
X minus 5.
Remember when we did this with the conjugates and square roots in them the other day? And all the square roots fell out? Kind of the same thing's going to happen. We're going to do the same thing with the i's. The parts you want to work with are the imaginary parts first. Always work with imaginary parts. So forget the x minus 5 right here. Let's start by taking this x times everything on the right first. So the x times x would be there. I'm going to bring my x minus 5 down. Just do that first. Okay. All right. Let's put the imaginaries together. X times x would be what, kids? X times the negative 1 over here would be. And then x times the negative I, wouldn't that be minus xi? Okay, so I've multiplied everything there by x. Now let's take everything times negative 1 over there. So negative 1 times x will be minus 1x. Negative 1 times negative 1 will be plus 1. Negative 1 times negative I would really be plus what? Okay. So now I've got to take I times everything over here. Positive I times positive x would be plus xi, wouldn't it? Okay. I times negative 1 would be minus I, wouldn't it?
Yeah.
And then, okay, this is where you really got to be careful. This is a plus I times a negative I, which is really going to be minus what?
What?
Minus I to the second, right?
Oh.
Well, it's really minus what kind of 1? Okay, so this part right here, this minus I to the second part, when I do this times this, you know that I to the second is equal to what value? So this is going to be like minus negative 1, or really what on the end, kids? Okay, now take a look inside of this. Anybody want to guess what's going to happen? Anybody want to guess? What's that? Because a positive times a negative would be negative, right? So this is like minus I squared. And minus I squared is the same as minus negative 1 when you're subtracting a negative. Okay? So help me. Let's see, I see a negative xi and a positive xi. What are they going to do to each other?
Cancel.
I see a positive I. Oh my gosh. I have a question for you. What just happened to your imaginary numbers? They left the building, right? And is that a good thing?
Yes.
Yeah, if you can get rid of the imaginaries here, you're in good shape. So guys, this is what this really becomes.
I squared something?
Yeah. And equals to 1.
That I squared is a plus 1 over here. Minus I squared is a plus 1 right there. Okay? All right, so let's see what we've got. This becomes x minus 5. Okay, help me combine some terms. X squared minus 2x.
Plus 1.
Plus 2.
Or plus 2.
Is this getting a little easier to work with now?
Yeah, no, no.
Now it is, right? So let's roll. We're going to take x minus 5 times x squared minus 2x. So x times x squared would be what? X times minus 2x would be a minus 2x squared. And x times the 2 would be plus 2x. Help me take everything times negative 5 now.
Yeah, no.
This will be negative 5x squared minus 10x.
Announcements regarding
plus
quiz time
10x,
this morning. Mrs. Zay,
And
with
this
time
time this
students,
will be
please report to the
negative
media center
10.
today. Mrs. Zay's with time students advisory, please report to the media center. Also, seniors, please check your email. You should have gotten a copy of the form for class motto, flower, colors, etc. Please take a minute during wait time today and get those things chosen. Thank you.
Kids, there it is.
Yep.
Okay, that's a good place to stop. Now, I will tell you, I sent out the online for this already. I think it was a whopping, I can't remember, 6 or 7 problems. So get a chance, get looking at it. If I don't have 3.5 stuff today, make sure I have it tomorrow for you. I think it's tomorrow night at 10. Because the one that I sent out for this one is not until Thursday, so tomorrow night that'll be you, okay? Yeah, usually. I know you got a lot of stuff going on, guys. You know I'm pretty flexible, right? Okay. So if you have any questions, stop in and see me, okay, you guys?
Are you?
And don't forget.